So we're talking about TTL control, and I've described the method of control wherein the signal output from whatever device you're using, whether it's a trigger scope or let's say a National Instruments board or any other device, that signal is going to output a voltage. And we're going to measure that voltage using any number of devices. We can use another piece of hardware like a shutter controller or a laser, or we can use a piece of hardware like, in this case, I'm using an oscilloscope. Now, what I've got configured here is, you can see this, this line here across the bottom. That line shows me the voltage output currently being sent from a pin on my trigger scope. So if I go to my trigger scope control software and I tell that pin that I want a equivalent of an on, or in this case a high command, what I'll see is that the voltage will change from 0 volts to 5 volts. Now I'm reading that here on this particular scope is showing 5.2 volts or so. So I can turn this thing on and I can turn it off. In this case, we're going to say drive to a low state. And so I have a switch. It's a remote switch. I can turn it on or off. Now, let's look at what happens in a real event in terms of if I'm running a camera and I want to do something at high speed. Well, you can see that if I type these things in or if I click on them, they're not going to be very fast. However, during an acquisition at high speed in a sequence, I can run a command that is pre-programmed. So in this case, I'm going to run a command that will give me a 30 millisecond high and low pulse. Okay, and that ran, and it ran so quickly we didn't get to see it. So what I'm going to do is I'm going to set my oscilloscope up for one capture, and I'll run it again. Okay, what we can see here is I've got a cursor up here, and you can see that the voltage when this signal was high was 5 volts. And then if we look over here, the signal is roughly 240 millivolts, or equivalent to 0 volts. Now, the width of this signal from the rising edge of the signal here, this is called the rising edge, to the falling edge of the signal on the right-hand side, that time window should be roughly 30 milliseconds is what I specified. And I actually see this BX minus AX here of 30.10 milliseconds. That's the time delta between these two sliders. So this is a 30 millisecond pulse. Now, if I had a camera set up to take a picture, if it was set to a strobe mode, what would happen is, as soon as this signal rose, what's called a rising signal, as soon as that occurred, then the camera would begin its exposure operation. Now, let's say my exposure was 10 milliseconds. Okay, so then here's nothing. The camera begins this exposure. 10 milliseconds occurs. The camera stops its exposure and then waits and continues waiting. On the other hand, if this was in bulb mode, then the camera would slave to the exposure time duration as specified by this signal. So in that case, the camera is doing nothing, 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 signal goes high, camera exposes for 30 milliseconds, and then ends its exposure on what's referred to here as the falling edge, or the falling of the signal back down to 0. And so this is how triggering works. It doesn't just work this way on cameras, it works this way on any other device. And in fact, many devices even use protocols based on this that just switch on and off at very high speed.